Okay, another interesting one. A 220, actually not a 220, but it's a 20 volt battery, which is labeled as VS, having an unknown internal resistance. So this battery has an unknown internal resistance, just like any other battery. It's switched into a series RC network. So we have a resistor, a capacitor, and here is a switch. Just think it's open right now. Assume capacitor is initially uncharged. So that would mean initially the voltage across that will be 0 volts. V of C, the voltage here rises to 10 volts in 1 second. Okay, after this switch is closed, after 1 second, it reaches 10 volt potential across the capacitor. We have to find out the value of the unknown resistance. The unknown resistance, which is the internal resistance, that of the battery, correct? Now, we already know that the voltage across the capacitor is equivalent to, in an RC network, is equivalent to V of S, which is this right here, 20 volt. V of S times 1 minus e to the power negative t over tau. And at 1 second, V of C is equals to 10, right? So hence I can transform this equation, replace VC with 10, and then rewrite the whole equation, and then it becomes something minus t, and I'm going to replace tau with RC. We all know that right here, right? I'm going to cancel 0 and 0 here, and then take 2 to the left hand side of the equation. So it becomes 1 over 2 equals to 1 minus e to the power negative t over RC, correct? If I rearrange this equation such that I take this part right here to the left, and I take this part to the right hand side of the equation then becomes e to the power negative t over RC equals to 1 minus 0.5, right? This 1 over 2 means 0.5. If I take it to the right hand side, this becomes 1 minus 0.5, which will be equals to 0.5, correct? Now, if I take ln on both sides, the left hand side of the equation will transform into negative t over RC equals to ln 0.5. And if you do the, if you use your calculator right here, actually let me do it right here, 0.5, that comes down to negative 0.693. Negative 0.693. This negative and this negative will cancel out. Hence, I can rewrite this equation t over RC, and know that t is actually 1 second. T is actually 1 second. So I can rewrite as 1 over RC equals to 0.693. And if I rearrange this equation such that RC will equal 1 over 0.693, and that would be equivalent to 1.44 seconds, right? 1.44 seconds. Now in this equation, RC equals to 1.44 seconds. The value of the capacitor is known. The value of the capacitor is known, which is basically 1 farad. And this resistance R here is not just this resistance, which is 0.5 ohm. It also includes, this R also includes the internal resistance, that of the battery, correct? So the total resistance here is going to be R plus Rx. The value of the resistance right here is given, which is 0.5 ohm. So I have written 0.5 plus Rx. How do we calculate Rx? Well, if you look at over here, because C capacitor value is 1 farad, then R becomes 1.44 ohms. R, you have RC, let me write it down over here again. RC equals to 1.44 seconds. This being 1 farad, that means R is going to be 1.44 ohms, right? And remember, this 1.44 ohms is the total resistance. We have to find out Rx. Rx is the internal resistance of the battery. Hence, I can transform this equation above. Rx equals to 1.44 ohms minus 0.5. If I rearrange this equation and write it down such, Rx equals to 1.44 ohm resistor, taking the 0.5 to the left hand side, minus 0.5 and then flipping it. Now Rx, simple math here, 1.44 ohm minus 0.5 ohm, and that gives you 0, let's see, 1.44 minus 0.5, and that gives you 0.94 ohms. That is the internal resistance of the battery, which was the unknown resistance. So the trick was, this resistance right here is actually the total resistance, right? The total resistance.